What's up guys? Happy Sunday. Thanks for tuning in to my latest video, The Life of a Jobbing Plumber. If you've not seen one before, it's basically a video blog of my working week, whatever jobs I've had on, and hopefully some tips and tricks. So I've had a really busy week this week. The gyms have reopened after lockdown, so I've been doing that after work. Had a boiler install, as well as loads of breakdowns, gas certificates, just my regular bread and butter stuff. This week, if you missed it, I did a live YouTube video where I did some pipe bending on the install I was doing. So if you did miss that, it was quite a nerve-wracking video for me, but I think it went all right. I had some good comments. I'll leave a link to that at the end of this video. This next job, there's a bit of a story behind it. So I got an email from the letting agency asking me if I could match or beat a quote for a new boiler at a property, and I recognised the property name because I do the gas certificate there, and it's a relatively new Ideal Logic system boiler. So I asked them for a bit more details, and apparently two other companies have been out and been throwing parts of this boiler and then decided that it's beyond economical repair, needs a new boiler. And the story goes, someone went out to replace a radiator. Once they replaced the radiator, they couldn't get the boiler to work. So then they power flushed the system and still couldn't get the boiler to work. And then they started putting parts on it. So it had a new expansion vessel, a new pump, a new return thermistor, and a new PCB. And this was all down to a circulation fault. Now, straight away, why you would need a new expansion vessel to cure a circulation problem, I don't know. Pump, yes. Return thermistor, yes. PCB, after all that, just sounds like they didn't really know what they were doing and they were clutching at straws. Now, as they've done a power flush on the system, that makes me think maybe there's a blockage on the system, or maybe there's a blockage at the boiler. But throwing a new boiler on the wall, if the blockage was in the system, they're going to have the same problem with the new boiler. So I asked them if I could ring the landlord, and I rang him and had a chat with him, and I just said, look, I don't mind fitting you a new boiler, but I'd rather go over and investigate the problem, because for some reason I don't think you need a new boiler. So he agreed to that, obviously agreed to pay for my time to investigate the fault. And I went over there with in mind I was going to prove, is it the system or is it the boiler? So I'll show you the video now. Again, this was when I wasn't really into YouTube, so I've only filmed a little bit, but I'll explain it with a diagram and then we'll have a chat at the end. This is the boiler, and they're getting an L1 fault, which is a lack of water flow or overheat on the flow temperature. And here's some of the parts that the other companies have fitted. So we've got the PCB, the return thermistor, the pump. They also put a new expansion vessel in, which isn't here, but you can see when I take the cover off, the new expansion vessel, they've actually kinked the hose, so it probably wasn't even worth them swapping it. But the last engineer to visit said that the condition of the boiler, it was so old and rusty that it wasn't worth putting any more parts on it, but it looks absolutely fine to me. Now, I've got the gut feeling that we've got a blockage on that main heat exchanger, or a blockage in the system. So my first thing I wanted to do was prove where the blockage was, on the boiler or on the system. So I've got this diagram I've drawn to show you the thought process of what went into what I did on this boiler. But basically, we've got the boiler there and we've got the system pipe work here. The boiler, return, flow to the system, return from the system, and a pump, isolation valves, and then this pipe work goes off to the system. It's a standard wire plan. We've got a hot water cylinder and radiators. Now, L1, low flow or overheat on this thermistor, because we've got no circulation. Now, the first thing I'll check on any boiler when I've been called out to no flow is check the isolation valves on the flow and return, because a lot of the time, especially on pressurized systems, the tenant will try and top the boiler pressure up themselves by watching a video they've seen on YouTube or whatever. And accidentally they'll shut one of these valves off. So that's the first thing I will always check. Make sure that these are open, because that could be the problem. Now, on this one in particular, it's very doubtful that was going to be the problem, because they've had two other engineers out and they've been swapping parts. So I imagine that they're clear. But what I need to know is my blockage on the boiler side or is it on the system side? Because if I put a new boiler on to a blocked system, I'm going to have the same fault with a new boiler. If it's the boiler, then we need to clear it. So the first thing I did was I drained the system and I disconnected the system from the boiler, at the valves, but we'll just show you from here. And then I got a coil of speed fit pipe, and I connected about 10 meters worth of pipe like that onto my pipe work. And then I filled it back up and I ran the boiler just through this coil of pipe. Because in my head I thought, if the blockage is on the system and we disconnect the system and just run the boiler through some pipe work and the boiler runs fine, then we've proved that the boiler's okay, the blockage is on the system. When I did that and fired it up, we still got the L1 fault. So it was still either overheating or not circulating just through that length of pipe. So I've proved there by doing that it's the boiler that's at fault. So now my plan was to try and remove the blockage from the main heat exchanger, and I'm going to do that using my Thoroughflush mains flushing unit. I'm going to try and explain this as best I can. So I took the flow and return isolation valves off the boiler and I attached my Thoroughflush mains flushing unit. I connected the cold inlet to the filling loop. So I've got live cold and then the flow and return on the Thoroughflush open, just connected to the boiler. And opening the cold now will pressurise the boiler as if it was just opening the filling loop. And the Thoroughflush pipe has become basically our system. And then opening the dump valve on the outlet valve on the Thoroughflush, I can pump that mains water into the boiler, around the heat exchanger and out, and hopefully clear up some of the debris. What I also thought this would allow me to do is once I got the boiler to 1 bar pressure, I would be able to run the boiler and see if I cleared this L1 fault. So at the minute, the Thoroughflush pipe becomes the same as that coil of 22mm speed fit I ran on, but we've got the bonus of I've been pumping some fresh water through and getting some of the crap out. Once it started to run clear, I fired the boiler up and I ran it, but I was still getting the L1 fault. It did improve slightly, it ran a bit longer than it did before, but I was still getting that L1 lockout. So I was trying to think of a way that I could get the boiler to run with the Thoroughflush attached whilst flushing the system, because in my head I thought if it's hot, it might help it. If we look in the installation manual for this Logic boiler and go to the fault finding section, we can see the L1 fault is a flow temperature overheat lockout or no water flow lockout. And then we scroll down to the fault finding section, and the third box down you'll say, is the flow return differential across the boiler in excess of 30 degrees? If we look at that on this diagram, we've got the return pipe here with the pump on and a thermistor there, and the flow pipe here that comes out of the heat exchanger with a thermistor. And the PCB is monitoring these two figures to make sure that we don't get more than a 30-degree difference. We know the ideal on a condensing boiler is 20 degrees, but anything over 30 and the boiler will lock out, go into an L1 fault. Now, while I've got my Thoroughflush connected here and I'm pumping mains water through it, and I want it to run, I want the boiler to get hot and run, I'm going to get more than a 30 degree difference because we've still got the blockage here. And having a Thoroughflush pumping mains water around a boiler isn't really ideal what the boiler was made for. So we're going to have an issue here. So what I decided to do, now I'm not recommending you do this because this is a safety device and you should never take alter a safety device. But basically what I did, I removed the flow thermistor and I removed the return thermistor, so they were just hanging in the air. Of course, with them off the pipe, they're then only sensing the air temperature. And because they're both together sensing the same temperature, the difference between the two will probably be somewhere like 0-1 degree. So the boiler isn't going to lock out on the difference in temperature. So that allowed me to run the boiler fire up just with my Thoroughflush going through it. And I think that's what helped me clear the blockage. So what's happening now is the boiler's fired up, the water's getting nice and hot, and the Thoroughflush is still pumping mains water around the boiler and to the drain. Now the way I've done this is I've balanced that outlet. You see the butterfly valve is almost shut. With the mains coming in and that coming out at that speed, that's keeping this boiler at just over 1 bar pressure. Because the boiler's got a pressure sensor on it, it needs to have 1 bar in it for the boiler to operate. So I've tweaked that so I've got about a steady 1 bar pressure. The thermistors are removed so the boiler's not sensing how hot it is. And I'm being very careful here, ready to turn the power off, because with the thermistors on, there's a very real chance of this boiler overheating to the point of it kettling. After about 5 minutes of doing this, there was an almighty banging and rumbling noise and a load of black shit shot out of that Thoroughflush, and I knew that it had cleared the blockage. So carried on doing it for another 5 minutes or so till I was happy, put it all back together, and you can see now the boiler's pluming away and no more L1 fault. So that was one of those jobs where you get a lot of satisfaction, because I got to the bottom of the problem. I proved to the landlord he didn't need a new boiler, and I've gained a customer for life, because I could have just gone back to him and said, yeah, this is the price for a new boiler, fitted a new boiler, got paid, and that's that. But now, because I went to the extra effort of doing what I did so he didn't have to spend on a new boiler and only had to pay my sort of time, in total it was about 3 hours, I've now got a customer for life, a loyal customer. So all's well that ends well. And it was a really interesting job for me, and it's nice to get a sort of problem like that and get to the bottom of it. I think I've mentioned this before, but this is how I sort of store my flushing gear. Not my Pro Flush machine, I keep that separate, but my Magna Cleanse and my Thoroughflush are in these Milwaukee. Now, someone told me to get, and I've not done it yet, the pack out feet to screw to this box so I can attach that to the top. But that's the idea anyway. So the top box, I've got all the connections I need for my what's it called, AD Magna Cleanse. So adapters to get me onto different filters and things. The AD adapters, I've got the Spiral Flush adapter in there, the hoses and the agitator. So that all lives in that top box, with the, obviously the Magna Cleanses in that box. And then let's pop this out. In the bottom one, the bigger one, this is where I keep my Thoroughflush. So I've got all different kinds of adapters and bits of pipe to get me onto any kind of system. Cam locks there for the Magna Cleanse, because you can run the Magna Cleanse in series with this. And then all the hoses to get onto my Thoroughflush. And the actual Thoroughflush itself is in this. There's quite a lot of water in there, I need to clean this out. So this is the unit you've just seen in that video. So I've got a full kit, full Thoroughflush kit to give away. So the unit itself, all the hoses, all the different adapters that you need. Just all you need to do to enter is, I'd like this to go to someone who's self-employed like myself, a one-man band, someone that's just started on their own, possibly a British gas engineer if you've just got the sack and you're starting on your own. Just leave me a comment, let me know why you want it, and I'll choose one of you at random to win the full Thoroughflush kit. This job I'm going to show you now is at my local church, and it was given to me sort of November time, and because we were in lockdown, no one was using the church. It meant I could go and do it in between other jobs, because obviously in the middle of winter you have a lot of breakdowns. So it was a nice job to have. I'm going to show you the footage I've got. Now, at the time of doing the job, I wasn't really thinking about YouTube. So there'll be some Instagram stuff, some stuff I filmed with YouTube in mind, and then I've sort of pieced it together and talking over some of it. Again, I had the radio on for the whole job, so a lot of it I had to dub over because you can't play the radio on YouTube. But hopefully you get an idea. It was a really interesting job for me. I've not done anything like it before, and a lot of you probably won't have done anything like it either, so I hope you enjoy it. So just doing a quote in the church. Capped one of these circuits off last year, I think it was, because it was leaking. But basically we've got, this is the return, and this pipe runs all the way underneath the seats, or the pews, whatever they're called, and then back up along, and then there's a TRV there. So we've got to replace, cut all this out and somehow get heating into this room. But it's massive. They were talking about vertical radiators on the walls. And we've got the normal radiators at the front. So I was thinking of a way to replace it. If I can get out. problem they've got. You can see where it's been leaking on the carpet, stained. So this pipe runs through the step. It's obviously a concrete step that's not been protected and has been leaking, so this one's isolated completely. Check this out. 2-inch copper, and that's a 5 metre length we're cutting. That's all the copper ripped out, loaded on the van, ready to go to the scrap merchants. 96 kilos in total. Won't mind that on every job. Right, so I've drawn out pretty much what we had when we started. So flow and return on the top bank and flow and return on the bottom bank. And that was the 2-inch copper that ran underneath the seats, dropped down and then came back underneath the seats. There was a TRV linked to a thermostat on the wall for each one. So we had a leak where it went through the concrete step there. We had 2 really bad leaks down in these bottom corners. So the idea was to rip all this out and then connect the flow and returns back in a loop and put the heaters underneath the 3 chairs. Originally we were going to do all 6 on both, so it would have been 12 in total. But what I suggested was we tried to do 3 first. So the bottom 3, because obviously the heat would be felt on the row behind. And then the second level, leaving pipe work in case in the future we decided it wasn't man enough, we weren't getting enough output for the room, because it's quite a big room, we could put 3 more in, or whatever we wanted really, because the pipe would be there. Now, the idea was to thread flow and return through the old copper pipe. So we're going to cut it and then thread it through, use it as a sleeve through the concrete. But it was virtually impossible on a big length of MLCP to get it through, especially these here were 45s, and sometimes there was also a 45 this side as well. And it just made it impossible. And when we got down to this side, you can see here it dropped down, elbow, another elbow down to get us to the 2 levels. So it was going to be impossible to get them through there. What we ended up doing here was having copper in some nice schoolboard clips mounted to the skirting board just to get us down. It looked quite nice actually when I'd finished. So yeah, in the end we ended up putting 2 pieces of pipe like that through each of the steps and then putting sockets on to join it. Now obviously sockets, it's not great, but they were surface sockets because they weren't going to be hidden. It just added cost onto the job, because if you add it on, that's 4 for each step. So 4, 8, 12, 16. So 32 sockets in total just to do that. It just added a bit of price onto the job, but we had to do it because I tried to get the 2 long lengths through the first one. I must have been there half an hour just trying, and I failed. So by the time you add it on, probably take you all day, if it was even possible to get them through. So at this stage in the job, all the copper's been removed. We've got new gate valves on the flow and return so we can fill the system back up so that the rest of the church can use the boilers. And I've got the 2 MLCP flow and returns through each of the steps. So 4 on this side and 4 on the left side. These are the heaters we used from a company called Smith's. They label them as perimeter heating, but I've just been calling them skirting rads. They were quite nice to work with. So on the inside, we've got the element. So basically that it's like aluminium, it's razor sharp. And then we've got a flow and return that run through the element. And then when you've got more than one, you just join them together. They slide together. So this is 2 1.5 metre lengths to make a 3 metre one. And we just solder them up. You can see one pipe's got a socket on. So male and female on each one. And then at the end, when you're finished, you just loop them together. So your flow comes in at the bottom and then it returns out the top on these. And then at this end, we've got a lock shield and TRV to go on. And then because we're using MLCP, multi-layer pipe, we've got some MLCP to copper adapters to get us into those valves. Right, I'm just going to go through some of the materials and kit I'm using on this job. So the majority of it is this, it's got cobweb on it, MLCP pipe, which is rock hard because, let's see if we can focus in on it. We've got plastic, then we've got a layer of metal, and then we've got another layer of plastic. In America, they will call this PEX. If you just read on that, this is a Meti PEX, PEX pipe. but in the UK we call it MLCP, multi-layer composite pipe. So it's multi-layered because it's plastic and metal. So if you bent it, you can bend it as a 90 and it will stay as a 90. Whatever shape you make out of it, it will stay because it's got the metal inside. So just doing it with one hand, but it don't spring back. So these are the fittings, MLCP fittings. Let me just break this metal. See if I can do this again with one hand. Normally these come off dead easy, but not when you want them to. So there's that metal outer, and then on the inside we've got 2 O-rings. So when you push your pipe on, the O-rings are going on the inside, and then this is what the gun crimps to grab the pipe and squeeze the fitting so that the O-rings are tight inside. So that's the inside of a fitting. It's the same on whether it's a T, a socket or whatever. There's the 2 O-rings inside. What you will find though, so this stuff I'm using here is 20mm. They're all different sizes. The 15mm is 16mm, 20mm, 25mm, just different sizes to what you'd expect from copper. But can you notice the internal bore on a fitting is a lot less than the pipe. There's our pipe diameter. Hold this up. Look at the inside of that fitting, so it does reduce it right down. So it's something to bear in mind when you're using MLCP. If you are using fittings, they do restrict the flow on the internal, so it's always best to go the next size up. So I just wanted to show you this. So when you use copper press, we mark the pipe and we mark the fitting to let us know that we've pressed it. Well, before we press it, we mark it to let us know that the pipe's gone in the fitting. On the MLCP, see both of these fittings have got pipe in, but we've got this little indicator window here. Now on the one that's not been pushed in, you can't see any pipe, you can still see the brass there through the window. On the fitting that's been done correctly, you can see the white pipe has come all the way. That's when you know it's safe to press it. So you've got to see that white pipe in there to let you know you've got it all the way into the fitting. Because this one here, because we can't see it, it could be only into there. So that's what you have to do. Once it's in like that, then you press it. This is the jaw TH20. If you look at the profile on that jaw, that's designed for the blue collar to sit in either of the ends there. This is a V22 jaw for a copper fitting. It's a completely different profile on the inside. Let's see if I can do them together. Well, you can see straight away it's wider. Let's see if I can open them. I can't do it. But different jaws. So this one does my copper fitting. Where's that gone? So then we've got MLCP to MLCP. So if we were joining them on, if you wanted to get to copper press, or you could put speed fit onto that, or you could solder onto that. If you were going to solder onto it, you'd take the O-rings off first, because obviously, you know, if you heat a fitting up, you're going to melt the O-rings. So that's an adapter there to go into back to copper. So put that on there. So now we've gone from 20mm MLCP to 22mm copper. It's one of them things, once you get used to it, you're absolutely fine with it because you know what you're doing. And you just cut this pipe, even though it's got metal in it, you just use the same cutters that you would use to cut speed fit, overflow pipe. Just goes on like that. And it cuts pretty easy. Yeah, MLCP. So the way we've done it is mounted a timber frame onto the underside of the seat, and then the heat emitter is screwed onto that. And then the pipes are going to run behind that, so behind the timber frame to connect on to go through the step. Soldering copper tails onto all of the emitters before we fit them to make it easier. What I was doing though is the ones that are joined together, I was soldering them in place because they're quite long, and also it's very easy to cut your fingers on that sharp metal on the emitters. So I did those in situ, but yeah, see there, soldered that in place, and then just connect the MLCP onto the pipes and then run them through. Now my dad came today, and this made me laugh because he only came to take all the old brass clips, the Munson rings, off the wall from under the seats. That's how tight he is. Right, so last night we got the bottom circuit done, which is the bottom row and the second row up, but there's only heaters on. You see there's one under that seat, there's the one that's joined together there, the 3 metre long one there, and there's one under there. And then all we've done is put lagging on so you can't see the white MLCP that runs behind. because when you're stood down here, I mean, there's only going to be the person who's the, I don't know, the vicar or whatever, going to be looking. But if you look further up where we've not finished yet, you see the white MLCP there, stands out like a sore thumb. So the grey makes it look a bit more tasteful. But left this running last night, and I've come in here this morning. There's snow outside. It's about 8:30. I've come to, because I've got a job boiler swap to do today, so I've come to get some of my fittings and kit. But it's absolutely toasty in here, and we've only done the bottom row. So there's 3 skirting rads on that bottom row. We've still got 3 more to put in on this third row up. So 1 there, 1 there, and 1 there. So when that's done, I think it's going to be, yeah, absolutely perfect in here. They wanted, because they were worried about the heat, didn't think this was going to be enough. They wanted another radiator going there, which would have meant getting pipes around this to join on. That's our flow there, that gate valve, and then the return is under this seat. It would have meant running pipes up and around that. So because the performance just with the 3 in is so good, had a little site meeting this morning, and I managed to talk them out of having that radiator there. So that's a little bit less work, because I don't think we need it. So yeah, gonna go and do a boiler swap now. Right, so now I'll show you the plan of what we decided to do. So we're gonna have 3 space heaters underneath the front 3 seats. So 1 there, 1 there, and 1 there. And then the idea was, so we took the flow, this is 1 continuous length of pipe. Sorry, paper's moving. So we took the flow all the way to the end, dropped down, and then into the first rad, along, into the second rad, along, and into the last rad. So that's our full flow. And then our return came along. Bloody paper. Our return came along, picked up that rad, picked up that rad, picked up that rad, and then we brought it along to the end, up to the top. Then I put an air vent there and just left an isolation valve, because the idea was if we needed more radiators here, then we just extend that to that rad, to that rad, and to that rad. So that's how the first one ended up, and we filled it up and we turned it on. And the amount of heat we got off these 3 emitters, we were running the boiler at max, but it got the room really nice and warm. So that made me think we're probably not going to need 3 more here, and we're certainly not going to need 6 here. So once we've got these 3 in, it's probably going to be enough. So on this one, rather than take the flow all the way, because if we're not going to add on to here, we don't need it there, we just stepped it down. So a nice copper pipe on the skirting again, and then all we did on this one was 2 pipes, flow and return to here, and then we put 2 air peps on there. So that's the flow, 2 pipes, picked up 1 rad, 2 rads, 3 rads. So you can see on the top one, once we learnt by doing the first one, we used a lot less pipe. Yeah. Right, we are finished here. I can't remember what I've said because it's been stretched out over so many weeks. We did the first 3, so this one, the middle bank, and this one off the bottom loop. And it was almost enough to heat the whole room. We had the boiler running at about 75 degrees though. So then we've put 1 on the 3rd row back, one in the middle bank, 1 on the end, reduced the boiler flow temperature down to 60, and this room is about 22, 23 degrees now. It's lovely. It's quite cold outside today. So it's been a success. I think the fact that you can't see that we've even been here, the other company that quoted against us were going to put vertical radiators on the walls and at the back, which I thought, you know, it would have just looked different. I think it just looks so much better because you don't even know we've been here. If we want to see underneath, we've got the flow and return there lagged, and then that's the heater there. I just think it's done a real good job, and because it's something I've never done before, I'm even more pleased. And there's, you know, we've got the next row up there. Obviously, me telling you it's nice and warm in here isn't as good as the person who gave us the job, who knows how cold it used to be in here, telling you. So she's going to come down later. I'm going to obviously hand over the job, and then we'll see what she thinks. So you had the issue with the pipe was leaking under the floor.
Yeah.
And this room wasn't getting hot enough, basically.
No.
And you had 2 quotes, did you?
We had 2 other quotes, yeah. What we really appreciated about you coming was that you came up with a completely different solution, which is fit for purpose, and we wouldn't have thought of it. So it's more in line actually with what we had originally, but much more efficient. And I could hardly believe it when I came in that day when it was snow on the ground and only half finished, and the place was warm. So we're just so thrilled. And it's discreet, you can't see any radiators on the wall, which was what we would have had before. We're thrilled with the outcome.
Good.
So,
and it was an interesting job for me as well, because I don't regularly do big, interesting jobs. It's normally, you know, a combi boiler on a wall, fixing a toilet. So it was a nice job for me to do as well. Lovely, thank you for that.